Hi, Assalamualaikum. Okay, today we're going to part 2 in air conditioning. Okay, previously we have seen on the refrigeration cycle. Okay, what are the components, what are the function, and then type of air conditioning. Okay, and then we know the application. And now in the part 2, we're going to look into the chill water and cooling tower operation. Okay, this one is for the centralized air conditioning system. And also, we're going to look at the general maintenance work in air conditioning, right? So, usually the centralized air conditioning system used for a big building with a many room. Okay, contohnya macam hotel, office, okay, yang banyak bilik, bangunan besar with the many room in which they can control the temperature separately in each room. So, they need the central air conditioning system. It's different from the normal air conditioning system like up here. Okay, the one is split unit, but this one for big building, so you have to use the central AC system. And we have different equipment in here. Okay, we have cooling tower, and we have this cooling loads in which involved with the AHU. Okay, air handling unit. Okay, usually we seen this in our lab. Okay, we can see that the AHU is on the ceiling, and these are the chiller. Chiller is where the refrigeration cycle happen. We have condenser in the chiller, or evaporator, we have the expansion valve, and also we have compressor in here. Okay, the difference is that they have cooling tower to let the heat off. Right. So let's see in detail. So these are there's actually two type of chiller, but we are focusing on the water cooled chiller.
Click the highlighted points to see major components, an exploded view of it, if applicable, and a list of parts that are most often needing replacement.
Okay, we can see the compressor there in the chiller. And then there's also evaporator. And there's also condenser to remove the heat from the refrigerant. Okay. And we also have expansion valve, okay, in which to control the refrigeration.
A water-cooled system uses large quantities of water, which are usually reclaimed in mechanisms such as a cooling tower. Large commercial chillers are usually water-cooled, as these are more efficient. The air handling unit moves the warmed air out of the space. The warm air flows over a cooling coil, and then the newly cooled air moves back into the space. Air handling units are used by both air-cooled and water-cooled chillers. Here is a diagram of the inner workings of a water-cooled chiller. You can see the component locations, the air handling units, and the cooling tower. Review these facts about water-cooled chillers that were covered in today's training.
Okay, so located in the building, right? Usually it's on top of the building, okay? Or sometimes they put it on the extension of the building, okay? On the ground, so it depends. Okay, these are the chiller and these are the cooling tower. I think you have seen this before, right? Okay. And these are the diagram for the chill water system. So chiller is the machine. Chiller is this one, yeah? Absorb heat from the water chiller and transfer to the liquid to the cooling tower. So cooling tower is this one, usually outdoor, and this one, the AHU unit, which supply the cold air inside the room, is in the indoor part. All right. So usually they use water and glycol mixture, okay, to transfer the heat. And in the chiller itself, it contains the water in and out, so they're in circling state. All right. So there's actually two parts: the releasing the heat part, and also this one is the or absorbing the heat. Okay, let's look detail. So this is another diagram. Okay, so outdoor is the cooling tower part and the indoor is the AHU unit. All right, and these are the chiller. The heat exchange is happening in here. Remove heat from a liquid. We have vapor compression using the refrigeration cycle. So the compressor is in here, as the evaporator, and also the condenser. And this also another diagram, okay, in the different arrangement, but they have the cooling tower, okay, they have the AHU, and they have the chiller here. Here the chiller explain more by having condenser, evaporator, the expansion valve, and also the compressor, okay. And chiller water system are used in many buildings, okay, because of their flexibility and operation costs compared to the split unit. Okay, if you use split unit for each of the room, it's going to cost you more. And also the quantity and temperature of the water supply must be sufficient. Okay, and then so that the exchange of heat can take place. Okay, these are the diagram with the real picture. Okay, these are the AHU. Alright, these are the chiller, and this is another type of cooling tower. Yeah, this is the square type. The one that I showed you earlier is the round type. And we have pump to pump the water. Okay, and the cool air in air conditioning application usually here after they make the heat exchange in the chiller. Okay, so the chill water go to the into the AHU, and then the blower will blow the cold air to the room. Okay, okay, let's watch a video on this chill water.
Chilled water cycle. Chilled water cycle consists of two basic components, which are air handling unit and water pump. Air handling unit. Air handling unit is a place where cold air is produced before it can be distributed. It consists of several key components such as cooling coil, fan motor, belting, filters and the casing. Chilled water produced in the evaporator will be flow into the air handling unit through a pipeline which is marked with dark blue color. This chilled water is known as chilled water supply. In air handling units, chilled water will then pass through the cooling coil. In the cooling coil, the hot air will go through the cooling coil and switch to cold air due to the heat transferred to chilled water. Cooling coil are commonly used in this system are tube and fin. After absorbing heat from the hot air, the chilled water will be known as chilled water return. Normally chilled water return pipe will be colored with light blue. Chilled water return will return back to the chiller to transfer the heat absorbed to the refrigerant in the evaporator. Water pump. This cycle will continue as long as the pump is functioning well. The pump used in the system is centrifugal type. The centrifugal pump works based on centrifugal force produced by the rotating impeller in the pump casing. For airflow system, it is operated using an auxiliary fan which to create the air cycle from the room and mix it with fresh air from the outside to the air handling unit and return back to the room. Type of fan used was centrifugal fan and powered by a motor and connected through a belting. The air flowing through a channel is called ducting. There are two types of air duct which are supply air duct and return air duct. These air ducts are coated with insulating material consisting of fiberglass wrapping with aluminium foil. It reduces heat transfer from the environment to the air duct. Air return to the air handling unit will pass through the filter before passing through a cooling coil and return back to the room. This to ensure that the air return into the room in a clean condition.
Okay, so I hope you understand on how the AHU work, okay, and then how they go to the chiller. So let's look more detail on the cooling, on the chiller. Okay, this is the real photo of a chiller, and it's quite big. Yeah, chiller is very big, and the chill water can range from 1.5 to 7 degrees Celsius. Okay, and these are the rate on the cooling capacity. Okay, it's about 53 to 5,300 kilowatt. Okay, let's go to the cooling tower. Okay, these are the round one. Cooling tower is where heat removal device in which they remove the heat that the water take from the chiller. Yeah, and then usually they have a few method in releasing the heat from the water, and I will show you in the video later on. And the condenser water, or we call it the chill water, that came from the chiller. Okay, and the removal of it will happen inside the cooling tower. Okay, let's watch this video on the cooling tower.
Cooling towers work with water-cooled chillers only. In the chiller, the warm water from a condenser flows into a cooling tower, which cools warm water down. Inside the cooling tower, the warm water flows up to a certain height, and then it travels downward. There are fans at a particular level which cool the air when it passes, which then cools the water.
Okay, that's basically how it works. It goes warm water inside the cooling tower, and it will go to the process removal heat and release as a cold water or chill water. This one using the square one, yeah. If you look at this one,
Cooling towers work with
square one. Okay, so let's look what actually the process inside it. Okay, from inside the cooling tower. Usually the warm water which carry the heat will go from above, okay, and there's a fan, and they spread the water downward, okay, and they have fill is made of, some of they say that made of plastic, okay. They go through this fill, and what happened, the heat is released, okay, released from the cooling tower, and the cold dry air will come from the bottom part of the cooling tower. So during this process, the water will release the heat, and when they gather here, it will become the cool water. Okay, usually what they have to do, they have to bring the water into direct contact of the air, so they have to spray it out here. So the dry air come in contact with the warm water, and then evaporative cooling effect happen here. Okay, let's watch the video on the process.
Condenser water cycle. Condenser water cycle consists of two basic components, which are cooling tower and water pump. Cooling tower. Cooling tower serves to cool down the temperature of condenser water that will be used to absorb heat in the refrigerant at the condenser. It consists of several components, which are motor, sprinkler blade, water fin, water reservoir, buoys, and make-up water tank. From the condenser in chiller, condenser water flow to the cooling tower with the help of a centrifugal pumps. This chilled water is called condenser water return. This condenser water will pass through the rotating sprinkler blades on cooling towers. This rotating rotor blades using pressure generated by the condenser water itself. Water will gush down through the fins to reduce the speed of water going down. This can delay the time, and the heat can be absorbed more effectively by the surrounding air that passing through the fins. Air through the fins is forced by a rotating fan on the sprinkler blade rotated by the motor. This fan rotates with its gusts upward. This will cause the air to move from the bottom to the top of the cooling tower where it is opposite to the flow of the condenser water. Condenser water which have eliminated their heat by the surrounding air will accumulate in the basin under the cooling tower. Condenser water that flowing out from cooling tower to the chiller is called condenser water supply. This condenser water will flow back to the chiller to continue heat absorbing work from the refrigerant. The buoy system at the water basin is connected to the makeup water tank. It works for adding water when the water level in the basin decreases at certain level due to evaporation. This condenser water cycle will continuously flow as long as the centrifugal pump is in good working condition.
Okay, so you see the process of releasing the heat, okay, inside the warm water. Okay, selecting a cooling tower. Okay, this one is not in your notes, so you can add on. In which by looking at these three factors, heat dissipation, okay, how the heat will release, circulated flow rate, okay, and also wet bulb temperature. So these are the three important factors. And also there are other factors in which they look at the cooling range, okay, mass flow of the rate of the water, the tower height, okay, how high they need, if they need to remove more heat, so maybe they have to increase the height, and then the air velocity, okay, to blow up or to make the release of the heat become faster, the capacity, the heat load, okay, and also the bulb temperature. Okay, these are the questions that we're going to discuss later on. All right, so see you in the next video.